my name is Noam, and I'm a software engineer at ActiveFence and a FinOps Foundation community member. And in the past year or so, I was part of a group leading the cloud cost reduction at ActiveFence and the FinOps journey. And I'm here to share with you today our learnings from that. So first, a bit about ActiveFence, because we will need that context later on the slide. So essentially what we do is protect platforms and the users from malicious content online. So basically every platform that has a user-generated content, it could be a social media platform or an e-commerce platform or instant messaging platform or any other platform that their users generate the content. We provide them an API to which they can set the user's media and get a probabilistic score of whether this content is malicious or not. And if you ask me to define malicious, then it depends on the context, each platform and their own pain, from white supremacy and hate speech to domestic terror and child safety and many other abuse areas tailor-made for the platform. So our agenda for today, we will start by taking a look and understanding financial team challenges within tech companies. We will then understand what is FinOps and how it comes to an aid. And we will end up by looking at ActiveFence's FinOps journey as a practical case study that hopefully you'll be able to take some practical action items to your organizations from. So our journey starts somewhere around 2008 with the progress made around virtual machines. Amazon released its EC2, Elastic Compute Cloud, which is essentially a compute unit you can book via a web interface. And if you think about it for a moment, the web interface makes an API call to Amazon Web Services backend servers to manage the infrastructure on your behalf. And that means you can do that also using code, and that led to a shift from manually managing and deploying your software to do that using code, which is now called as infrastructure and code. And that enabled a lot of automation around infrastructure. Later on, also allowed automation around scale and provisioning, and we now call that DevOps. So with the cloud era, software engineers were no longer just responsible for the software itself and the application code alone, but also to the CI/CD and automations around infrastructure. And if you think about it from financial perspective, the pricing model of those cloud providers was pay as you go, pay based on the demand, meaning if 1 month I used one machine, I will pay the price of one machine, and if the other I used none, I will pay nothing. And system became more and more complex, and with the progress made around containerizations, cloud providers offer more and more services with different pricing model. So you are now able to deploy serverless services and get out of the box fully managed databases and security solutions and many other services, each one with their own pricing model. So from financial perspective, what it means is if prior to the cloud era, organizations either bought or rented their data centers, meaning costs were usually fixed. You knew how much you're going to pay on a monthly basis for the servers. But with the cloud era, as we just saw, costs are now changing on a monthly basis, and this is significant because companies need to properly budget themselves, and therefore will always prefer fixed cost over changes cost, even if the fixed costs are higher, because it's easier to properly forecast and budget. So for financial teams within tech companies, this is very frustrating, because financial teams' responsibilities are mainly steering the organization towards profitability and sustainability growth. And they, of course, do that by forecasting and budgeting. So and moreover, the financial team's ability to improve their forecasting is very limited because the cloud cost components are heavily based on engineering decisions and considerations. So with the cloud era, there is now a new black box, the cloud cost, which financial team ability to better understand and deal with is very, very limited because it's based on engineering decisions. And this is where FinOps comes to an aid. Essentially, because it's based on engineering decisions, software engineers are the one that can best fill that gap by understanding the cost implications of their engineering decisions and by embracing FinOps principles. And let's define FinOps first. So this is the, you don't have to read it, but this is the definition of the FinOps foundation. And we'll define it a bit shorter as a cultural change enables organization making data-driven spending decisions. And it's important to know that it's defined as a cultural change. And this is how we implemented it at ActiveFence. So it compounds of 4 components: increasing visibility over our cloud cost, creating a rapid feedback loop. Of course, you can't avoid resource optimization and development of cost awareness mindset. Now, it's important to mention that you can find many flavors of this workflow online. I'm just presenting one worked for us and as we implemented it at ActiveFence. Now, we will start by understanding the visibility component. And if you think about it for a moment, we all use systems like Datadog and Grafana to monitor our system's health, right? So if ActiveFence's product is an API, you can probably guess we have somewhere a dashboard with some monitors, like how many successful requests we had to the API and how many failed requests we had to the API, and what was the nature of the failures. Was it those 400 errors or 500 errors? And what is the latency, and many monitors that allow us to detect latency anomalies. And of course, many other monitors that in the end help us monitor our system's health. So why is it less trivial to monitor what and how we spend money over our cloud costs? And the answer, of course, is that it shouldn't be less trivial. And the first step towards increasing your visibility of your cloud cost is adopting a cloud cost monitoring platform. And here we can see a FinOps survey done by the FinOps Foundation, showing the adoption of different cloud monitoring tools. And as you can see, there are plenty. So you can just start by picking one. And once you adopted a cloud monitoring platform, gaining control over your cloud cost involves tagging cloud resources with organizational unit information and business context. And the tagging is essentially assigning metadata, the tags, to your cloud resources. And those tags allow you to categorize your cloud expenses in a granular way, which later make it easier to understand where and how money is being spent. So once you adopt the cloud monitoring platform, the data will look something like that. So you can see how much you spend on a monthly basis in this example, but you can't see how money is being spent, and you can't yet detect anomalies and evaluate ROI of different components. And after a few iterations of resource tagging, the data will look something like that. And here, each color is a different tag. And from that, we can create many interesting views that allow us to better understand what's going on in the cost components. So we can ask the data, for example, or create a view that will help us understand how much the R&D are spending, or how much the data group within the R&D are spending, or how much my production environment cost me, or my dev environment cost me, or my dev environment comparing to my production. I can evaluate the ROI of different jobs and model retraining, and many other interesting views can be created now from the data tagged by business context. And so essentially, if we defined earlier the cloud cost component as a black box, then the visibility component of the workflow is our windows to that black box. Now, the process of developing a healthy FinOps culture iterates to the different steps more than once. And ideally, we would like our feedback, like changing the resource allocation or the tags updating, to be visible in the dashboard as soon as possible, which later allow us to measure the impact of our changes. Now, the fast feedback here lays the ground for further optimization and the development of the cost awareness mindset, because ideally, when an engineer implements changes aimed to reduce the cloud cost, we shouldn't have to wait an entire month to evaluate the impact of the changes via a report. But that being said, it's important to mention that the cost data usually won't appear in real time in the cost management tools, and it might take a few days, unlike you would expect from your application monitoring platform. The third component we will take a look at is the resource optimization. Now, once we have a good visibility into the cloud cost and it's broken down to different areas and business context and organization unit, it is possible to evaluate the ROI of different jobs and start optimizing them. Now, we can talk an extra hour just about resource optimization, and it depends a lot on your technology and your business context. So we won't dive too deep into that, but I will share a few examples. I will start by saying that you should start by optimizing the more expensive components of your cloud costs. So usually you would start from the compute units, and then you move towards storage and databases, and then networking, and then other peripheral cost components. I will also mention that although it might sound intuitive, the main goal here is to optimize the system, not to reduce the cost. And that after a few iterations of that workflow, it's sometimes easy to forget that reduced cost is a metric for optimized system, but the main goal here is to have an optimized system in the end. So we will start by looking at a few examples, and one of them is right-sizing your resources. Now, often cloud resources are either over-provisioned, which lead to unnecessary costs, or under-provisioned, which lead to poor performance, and right-sizing involves the adjustment of the size and capacity of resources to meet the demand efficiently. Now, although that might sound trivial, if you think about a process of an engineer developing a new service, and let's say that service is deployed via Kubernetes, and if you're not familiar with Kubernetes, you need to have some spec file that declares how many CPUs and how much memory an application instance would need. So if you think about a process of an engineer developing a new service like that, usually what they would do is take a reference file for those specs and use that. They won't develop it from scratch. So normally what I would do is copy that from a sibling service or another service I recently worked on, change a few variable names, and move forward with that with my development process. And by the time that service gets to your production environment, it is likely to forget to revisit the requested resources and see if those are actually meet the actual usage, and thus might lead to over provisioning. Another example is auto scaling. Now, auto scaling dynamically adjusts the number of active resources, your virtual machines or your containers, based on the current demand. And by scaling up during peak demand and scaling down during low usage period, auto scaling ensures that you pay only for the resources you need and when you need them. And this is an example of our work we did a few months ago at ActiveFence. So on the left, we can see the amount of requested resources one of our deployments had, and this is in kilo cores, it's important to mention. Now, if you're not familiar with Kubernetes, the amount of requested resources are the amount of provisioned resources, and hence the amount of build resources in the end. And we can see here it was picked, again, on the left, it picked at 3,800 cores. Now, on the right, we can see the actual used resources by the same deployment, and this is not in kilocores. So the peak usage was around 380 cores. And we implemented a change somewhere around November 19th, as you can see from the graph, that addresses both the auto-scaling metric and right-sizing the resources. Now, it's important to mention that the load on that service hasn't changed during the time period, and yet we were able to do the same work with 10% of the resources, simply by right-sizing the requested resources and fixing the auto-scaling metrics, or adjusting the auto-scaling metrics properly. Another example for resource optimization is selecting the right pricing model. Now, selecting the right pricing model can be challenging, as cloud providers have many different services with many different pricing models, and each one has its own benefits and conditions. And on the other hand, different applications and services have different resource requirements and different usage patterns. So matching the right pricing model to your resource requirements may be challenging and time-consuming. But that being said, not taking advantage of cost-effective pricing models may lead to overpayment for your cloud resources. So you should always consider using spots versus on-demand, or some combination of the two, or of course reserved instances. And for other managed services like managed databases, there is usually some kind of provision capacity you can deploy, which is always recommended for predictable workloads. And the last example for resource optimization is lifecycle rules. So those are essentially involves implementing policies for creation, usage, and decommission of resources that can prevent resources from being forgotten and incurring ongoing costs. So all the snapshots, all the buckets, obsolete volumes, etc., should all be attached to some kind of lifecycle rules. So a short recap about where are we at the workflow. So we started by taking a look at the visibility component as our windows to the cloud cost black box. And we then took a look at the importance of rapid feedback for optimizing the entire workflow process. We looked at resource optimizations, which of course reduce a lot our costs. And we will end up by looking at the cost awareness mindset development. And this refers to the cultural aspect of FinOps. Now, if you think about for a moment, if you think about the process of getting a new mouse from your IT department or an extra monitor, in most places you would need to submit some kind of a ticket, and if it's a spatial ergonomic mouse or an extra monitor to your home office, you might need your manager to reply to it and help you push it. And after a day or two or a week, you would normally get the extra gadget to your working station. But you could probably commit the following changes without and if you don't see the essence of the changes here, I'm increasing the amount of replicas of given deployment from 3 to 300. So you could probably commit the following changes either without a review, because you have admin permissions to the repo and you can bypass the code approval, or with a very quick one from one of your peers. Now, this will cost my company much more than an extra mouse or an extra monitor. So, and my point here isn't that you should submit a ticket and wait a few days for every commit you make. Totally not. But that engineers should keep in mind that with almost every commit you make, you essentially make a financial commitment on your company's behalf. And this is important because engineers traditionally focus on performance and reliability and speed, but FinOps now requires them to also be aware of the cost implications of their engineering decisions. And at ActiveFence, we expect it to be taken into account as part of a design. So if an engineer developing a new feature that requires an extra database table, we expect them to consider either if the workloads can be predictable, and thus we can leverage some kind of a pricing model or not. And if a scientist develops or improves a model that requires a larger GPU, we expect them to raise the question of whether the model accuracy improvement worth the additional cost of the larger GPU. And it's important because getting to true optimization can only be by leveraging engineering context on a feature and the cloud knowledge. It won't be as efficient if we select an engineer to be a FinOps engineer and we'll let them manage the entire cloud cost domain for the entire system. And an example for that I can share from last week we had. So one of our engineers, while working on a feature, found that in some scenarios, which are relatively common, we index a lot of data we don't really need on Elasticsearch. And by removing that for those relevant flows, he reduced our write operations by 50%. Now, the essence of the change here is not what's important. Of course, we should all avoid the redundant write operations, but the important part here is the cost awareness mindset that engineer had, because he worked on an unrelated feature, but due to his familiarity with the code base and this mindset, he was able to introduce and suggest such significant improvement. And cost awareness is critical because as company grows, its cloud costs grow as well. And having engineers with a FinOps mindset that review the dashboards and have an ongoing awareness of the cost of their actions and feature incur will, in the end, decrease waste and enable you to focus your resources on building great things. Now, I went through those a bit quickly, but you can find all of that among other fascinating things at ActiveFence's engineering blog. And of course, we are hiring, so you're welcome to search for your next job in our career site. And thank you very much for listening.